Hello everyone, how are you? Today, ready to talk about Pokemon. I accepted to give that talk at the last minute, so there's going to be some rough edges, but everything's going to be fine. I'm so excited to talk about Pokemon today, and robots and electronics and stuff. I want to make sure that you know that I'm an adult, and and yeah, let's get started. My name is Sophie. Yes. Sorry. Thank you. Thank you. So my name is Sophie Déziel. I'm a Rails developer at Acquisio. I'm also a content creator on Twitch. I do electronics live. I make mistakes, I fail, and I succeed. If you want to watch me build robots or a keychain Flappy Bird, all sort of things with those awesome components, you can find me at Sophie Déziel. This is what I look like when I tweet, so be warned. And here is my partner in crime. We built the robot. We were two in a team. Guy Pesmier, he's the co-founder of Outermind, game development studio that is known for making games with PewDiePie and H3H3, other amazing games as well. He's at GDC this week, so I don't have the robot with me. He's in possession of the robot. And also they're looking for Unity developers. I know for a fact that everybody sitting in this room is awesome, so if you are interested, come talk to me, I'll put you in contact. I'll be more than happy to put you in contact. He's also an adult, I want to make that clear. And yeah, he's a big, also a big fan of old school video game collectioner and everything. So he's the one that came up with the idea of the robot. Who in this room remembers the Pokemon cards? Who owned cards? Who had those very special shiny cards with the holographic design? They were awesome, right? You were the coolest kid in the school when you had those. There's a similar concept in recent games and more old games where like you have to catch all of the Pokemons, but there's also the very special one we call Shiny Pokémons. They have a slightly different color. They are hard to find. And that's what, and some people are very, very, very serious about catching them, especially Giz. In Pokemon Pikachu and Let's Go Pikachu and Let's Go Eevee, odds of catching such Pokemons can be increased with using items or performing certain actions. But other Pokemons, you have to exchange stuff. And there's a series of very, 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 very simple actions, which are pressing A, pressing A, pressing A, pressing A, over and over again. And while hunting shiny Pokemons can be relaxing in some cases, in most cases, in that case, that's pretty soul-sucking. So, wanted to automate this. We're geeks. Let's do this. So, can we build a robot that would press A, press A, press A, press A, press A, press A, over and over again, but resetting the game as well, because you have to exchange Pokemons. You have items in your inventory that if you run out of them, you have to start over. You reset the game without saving, and you start again. So sure, a robot can do that, but how can we, like we can control the game, but how can we make decisions? Like, is it a shiny Pokemon to stop the robot or save or do whatever? How how do we, we need input and output. First challenge, controlling the game. That was fairly easy. Next slide, okay. We used servo motors. They are highly available, cheap, easy to find. And it's basically, I have some here. Well, I have a lot of material here that I can show you later. But you can precisely position the arm to an angle, just to press on a button. It's easy to control. We thought of opening the controller, destroying it, just to bypass some inputs in it. The thing is, we wanted to make a YouTube video out of it, and we knew that some teenagers, curious teenagers, would want to do this. And I prefer encouraging to build something instead of destroying something. And a Joy-Con is pretty expensive. We can afford it. But like, there's some, we prefer to go with the motors. We tried other stuff, like linear actuators. It's like a small piston that would press on things, but the very, very small ones that we needed are pretty hard to find. Servo motors are everywhere, but the actuators were not easy to find. We found huge ones, but that would just smash the controller. We tried also solenoids, but they were not reliable enough for our purpose. So we went with servos. For the input, that was pretty easy. This is a webcam that we used. Because we're both content creators on Twitch and YouTube, we had like 5 of those. That exact model, because they are cheap. They're easy to find as well. Most people have a webcam, either built in on their computer, but also those lying around. So that's something people can use to reproduce. We went with that also because it's easy. It's plug and play on most computers or Raspberry Pis, which we used. It's not mandatory for that project, but we decided to go with a Pi. It was easy to install. We were able to grab the image pretty easily with a script. We thought of using a game capture device that we also use, but those are not easy to interact with using code. They require also a lot of processing power, and we don't require like super high definition and exact image precision and all. We only needed 1 pixel. Why? Because we wanted to detect what color one specific Pokemon is. It's not moving a lot in the screen, so we just need 1 pixel, the color of 1 pixel. So we put the camera very, very close to the screen, centered on the Pokemon, the region that is another color, and take that pixel. And that worked. So we we have plans for having a working prototype. We can go forward building it. Why is it? Please change. I think the battery might be, I can use mine. Well, I'll just... Life problem solving. That's my life. It's detecting. Maybe it's in conflict with the other one. I have to turn it on. Yay. Okay. So, no problem. So we can go forward with the talk and with the project. So We decided to use a Raspberry Pi because we wanted to make the robot autonomous. Giz has to use his laptop to go to work, and like we can't dedicate a computer for it. So we decided to use that. It's pretty inexpensive, and also everything that we build for the Raspberry Pi is easily shareable with the world, so people can build it themselves with the Raspberry Pi or not. Like everything we do for it will be easy to share. We need it to be reliable. We need it to be precise and comfortable, configurable. That's the challenge that we're trying to solve in the process of building the robot. Oh, okay. Maybe the problem is my computer. So to make it reliable, it has to work for hours, unsupervised, because maybe it's the screen. It has to be unsupervised because the Pokemons that we want to catch, the odds are 1 out of 4,096. So it will have to do the process for entire days, and it did. We have to have perfect timing between those 8 presses to be able to detect when to take that specific pixel color like the script has to be precise. And the robot itself, you see what we built here for the buttons and the servo motors must not move. If the controller moves, there's no button presses anymore. So it has to be able to work for hours and hours to work. To control the servo motors, you see here they're not plugged because we are early in the project. We used Arduino to be able to test the script easily on our computers instead of on the Raspberry Pi. It made the development process way faster. Also, it can enable people to control their own robot from their computers instead of a Raspberry Pi. It makes the project more modular, and you can adapt it more easily to your needs. If you want to build one that's specifically for Pokemon, for whatever usage you want to build a robot, Arduino is a very good solution. So we used the library called Firmata, which allows communication between a computer and the Arduino to have code execute on the computer's side and send commands. Very easy to use, easy to install. It's provided with the Arduino IDE, which provides also a lot of tools for people that are starting with electronics. And controlling one or several servo motors with that is a matter of setting, okay, I want that servo to that angle, and poof, you have it move. And it's easy to use. As I said, for the webcam, computer vision is only 1 pixel, but there's a whole stack behind it to make it possible. First of all, we used Motion and Motion Eye, open source project that is very easy to install on Linux, that gives streaming capabilities, HTTP streaming on your webcam. So you can integrate it to a web page. You can grab the image using an HTTP call. I recommend that project if you want to build something that you need some monitoring, like an aquarium or a roof garden. You want to put a webcam and set up monitoring very easily. You can set that. It took me 10 minutes to do. So and it's well documented as well. So if you want to, I recommend this. Also, for processing the image and grabbing that specific pixel, I used Ruby, the programming language, my favorite one. And the libraries are Magic with Magic Wand and like open source image processing projects. Very easy. I said take the image, take that pixel. What's the hue? I'm taking, like, you can use RGB. You can also have hue, saturation, and light. So I used the hue to determine is it a shiny Pokemon or not. And on that part, we set a range of what is the normal color for the Pokemon. And we decided to prefer false positive than false negative. Just to optimize for time, we prefer to restart the robot instead of missing that glorious shiny Pokemon. And because we needed a lot of config, we needed to fine-tune everything. Instead of writing numbers in the code and re-uploading all the time, I made an interface to make everything easier. But also, it will be easier for people who want to build a similar robot to interact with it. It's also more pleasant on the long term. And also, it's better to present an interface when you're live streaming the project or when you're making a video on YouTube. It's more appealing, but it's pleasant for everybody. Because the script was written in Ruby, it made sense to build the interface in Rails. So I could start a script very like that. All the numbers are in the database. Could be a JSON file, could be whatever way you want to store the numbers. But to pass it around to the script was very, very easy. Putting it all together, of course, as I said, I used a Raspberry Pi. If you don't know what this is a computer. It's a very, very small, inexpensive computer. Not very powerful, but more than we needed for the project. The operating system and everything is on a very small SD card, so you can create an image and share it. And because it's Linux, you can use all the open source ecosystem. You can install whatever you want on it. Has some USB ports for the webcam, and we can let it run for hours. And we have our prototype. Now it has to work for hours. We were able to do some test runs, and of course, we ran into problems. Of course, must not stop us. The first one was the servo motors. The first one that we had were unreliable. We broke 3 by overheating, we think. We're not sure. I dismantled one just to see what's inside. I already know what's inside, but I wanted to see it. I think the chip overheated, and well, there's different grades of servos, and so we found another brand that was way more reliable, and now it's working. It has almost 200 hours of operation without any failure. So we found the right hardware now. We also have lots of things to improve, things that we haven't planned, like just a very small thing, like raising the arms of the servo motors to be able to release the controller when you want to play another game or do whatever you want with your Nintendo Switch. We had to implement that because the controller would be prisoner of the robot. So we had to add some features, controls, everything. Also, we're 2 people working on the same robot, which means we can't test everything when we're at home and the other person has the robot. So we had to find processes to be able to update the code on the robot. Of course, I used Git and GitHub. First of all, because I wanted to open source everything, but also because it's easy then to update the code on the Raspberry Pi and test stuff. We also added communication features, like when the robot thinks it found a shiny Pokemon, we send an SMS with an image using Twilio. We're still on the free trial. They give you like $15 of credit. We're still on it because every SMS could cost less than a cent. So for now, it's been pretty much free for us. It also tweets, because a lot of people are interested in that project. They saw us build it live. So we integrated Twitter in it. So, and I forgot to put the Twitter handle, but I can give it to you later, and you can see what Pokemons it catched. So now that we have a working robot, there's a lot of stuff that we want to make then, because we have a working prototype, people want to build it, but there's a lot that we can do, like we want to make the calibration process easier. Let's say the angle at which the servo has to go to press on the button, it's not that easy right now. We want to make it easier because it must not press too hard, otherwise the servo motor will it will heat up. And we want to improve the robot's timing so it can do more iteration in a day. And the biggest thing, there's a new Pokemon game that is coming in the next few months. So we want to get ready for that edition. It's Pokemon Shield and Sword. So yes, we want to get ready for that. Do you want to build it? I hope so. Well, you don't have to build a robot for Pokemon specifically. Those things that I showed you can be used for many other applications. Like servo motors can be used for almost anything. If you want to control your aquarium, go for it. Like the webcam and maybe a servo motor that will control like feeding the fishes or monitoring the CO2 or whatever you like. What I talked about can be applied there. If you want to build specifically that one, all the code is there. You can get inspired also. And it was very important to me to share everything so that people can be empowered with new techniques and what they can do with open source software and hardware. You can also modify it. I'm very open to pull requests. If you want to add lights or lasers or whatever you want to add to it to make it more fun and cool, you can remove the Arduino part to use the pins on the Raspberry Pi if you want, or you can do the opposite, remove the Raspberry Pi and do everything from your computer. You can improve the interface, you can adapt the code base for whatever other application you would have. I have here a small list. It's not everything open source that I've used, but it's the most important parts. There's a lot to it. The things that are closed source are mostly the webcam. Maybe it's plug-and-play driver, and everything else was mostly open source. So, thank you very much. Yeah, if you have questions, I am very, very open to them. I also have a lot of things that if you're curious, we can talk about specific things later if you have questions about how you can build something else.
Did you catch it?
Yes.
Do you have a picture?
Yes. I'll go in mirror mode because it's going to be easier. Let's go on Twitter. So that's the Twitter account for the robot. And we got here a Kabuto. That one is Ammonite. Sandshrew evolved in Sandslash. We had a Sandshrew. Another Sandshrew. And I think that's it. That was the development process. The servo that broke. So we tried to have an interesting Twitter account. So yes, we have. So yes, we have pictures.
One last question. I'm loud, I don't need a mic. So just to make sure I understood, the Arduino was used to control the servos and the Raspberry Pi was used to communicate with the webcam?
Yeah, and it gave orders to the Arduino.
Oh, okay.
Yeah, those two are connected.
So thank you very much.
Thank you for having me.